All right. Thank you for joining me at this ungodly hour. Especially you, Brad. You've got to travel into the campus to join in, so I appreciate that. Thank you. All right. So this is the next cluster of units that we've got around routing and switching. And the units are ICT 10, 419, 417, and ICT NWK 405. So 417 and 419 are basically our routing and switching units, and 405 is our wireless unit. Okay, so the course that we're using as our foundation is Cisco Netacad's switching, routing, and wireless essentials. So there's two chapters in this course that deal with basic wireless info. Now this is a little bit more detailed than what you'll get equivalent to like an introduction course, in that we actually delve into and set up a wireless controller. So we're not just doing what you would do at home in this unit, so it's a little bit more interesting. And then we'll move on and build on to more complex routing and switching configurations, mainly more to do with switching than routing, but we do still do a bit more routing information as we build up. So what's it look like when we deliver it? And I'll tell you, it takes us to the end of the year, 20 sessions, basically clustered Netacad exams again. Some of these chapters are big, some are quite small, like switching concepts, only like 18 slides. So some weeks we'll have a heavy load, some weeks we'll have very little. So just to be aware of that. So today we'll basically do a refresh of the first course, the Introduction to Networks, Basic Device Configuration. Then we've got switching concepts, VLANs, Inter-VLAN routing, and then a combined exam after chapter 4. Then spanning tree protocol and EtherChannel, which are basically the protocol that handles communicating between switches and combining links together in switching. And then we'll have Cisco's version of DHCP and hotspot routing protocol for chapter 9. Then we'll move on to some security configuration as Cisco implements it. And then chapters 12 and 13, we deal with our wireless chapters, our wireless LAN. And then 14, 15, and 16, we come into our finishing off with a little bit more routing information on setting up static routing. And that ties off the concepts for this cluster. And then we've got 4 weeks where we just catch up on the lab work, and gives us a bit of time to do a bit of review on the theory. Now, during the course of the 20 weeks, you'll have unit assessments. Now, again, these are via My Learning. and apparently I need to submit a particular form to get this unit added to the course that should have been added to the course when the course was set up. So I need to go find the appropriate form to get it added, and that's ICT TEN 419, so that it's in my learning. Alright, so let's delve into the review of basic device configuration. Hopefully it will be review. So we'll be looking at the basic Cisco switch configuration. We'll have a look at the ports and basic secure management, i.e. passwords and things like that, and then the basics of a router as well, and a bit of troubleshooting. So basically some of the review of the first ITN course that we did, and we'll so I'll try to power on through most of this fairly quickly, because most of it should be review from the ITN course. So power on self-test post is stored in read-only memory, and it basically does a self-check of the hardware to make sure everything's in working order, and then moves on to loading the bootloader, which basically is the program that loads up your operating system and initializes all the systems to work together. So initializes the memory mapping, the speed of interface talking, and then loads up the actual operating system and gets that underway. So we can massage this system of where it finds the operating system with the boot system command. There is a default boot system, as we saw here. Looks at the flash. Okay. It will load up the first operating system in the flash by default. So you can have multiple operating systems loaded in flash, and to tell it which one to load, we use the boot system flash and basically the name and location of where that operating system is located. So this is really good when you're wanting to evaluate the next version of operating system that's been released before you push it out fully. You can actually preload it into your hard drive. Remember, flash is your hard drive on these devices, and you can load the new operating system, test it, make sure it functions as you want it, with the old one still there as a backup, so you can quickly fall back to it if things go wrong. On the front of the switches, we have a set of LED lights, and these give us important information about the status and running of the switch. So I won't read you out all of the line by line. You are going to be reading the chapters, remember, so I'll let you do word for word. But basically, the point system is whether or not it's got power, so that one's pretty straightforward. And then you've got port speeds, duplex, that tell you what sort of speed and status that these ports are running on. And down the bottom here we have the mode button, which changes the mode between status, duplex speed, pointer in Power over Ethernet statuses, so that these lights can change function depending on the hardware in place. You also need to do a combination of powering on and holding the mode key to do a reset function, which is one of the labs I always enjoy doing, generally when somebody mucks something up, because you've got to actually pull the power cord because there's no on-off button on the switch, and then plug it back in while holding the front. And doing that in a live rack can be interesting. Alright, so this table is basically giving us what the status lights mean when they're blinking green or amber, and whether they're, so take a few minutes to remember this chart, because I can pretty much guarantee you there'll be questions about this sort of thing on their exams. It's just the nasty sort of route memory stuff that they require you to learn. Okay, so as I said, recovery, so holding it in until the system LED turns briefly amber and then goes to a solid green. Then you can release the mode button, and then you have to actually go through the process of loading the bootloader and operating system. Okay, so you can do this without loading the config file, and that way you can actually get into privilege mode and then load the config file so you can change the passwords and not have to rewrite all of your config file, for example, doing password recovery. Console cable from a desktop or a laptop into the console port. Now, in today's switches, we have multiple different console ports. We now have a USB connector as a console, as well as the old RS-232 serial connector as well. But let me just say, when you're working in the field, it pays to have both in your bag, because the older equipment that you'll still come across does not have the USB console. It only has the RS-232 connection. So it's always advisable to have both cable types in your bag. Switched virtual interface is our VLAN interface. Now remember, a switch is a layer 2 device, and it only has a virtual layer 3 interface, so our VLAN. And when we come to having a look at configuring the VLANs and how the VLANs interact with each other to determine whose interface is current, later on we'll have a look at how that swaps and changes. So you can create a VLAN with a number. Most switches will cater for about 4,000 VLANs, and there are several VLANs that are configured by default, VLAN 1 being the primary default VLAN, but these VLANs will not be on unless you have ports associated with the VLAN. Okay, so you've got to have one physical connection for a VLAN to be active on the switch. Now, but by default, all ports are members of VLAN 1, so we highly recommend that you do not use VLAN 1 in a production environment, and you disassociate ports with VLAN 1. Okay, so last bit there, when you're doing dual stacks, you need to use the command SDM prefer dual IPv4 and v6 default, and then reload the switch to implement that. So as a refresher, config terminal from the global privilege mode into global config mode, then go in the interface VLAN 99, give it an IP address, do the no shutdown to turn the interface on, End or Control Z to exit out of config, and then save your configuration file so that it's still there when you reboot. Setting a default gateway in a switch is done via the IP default gateway command. Again, just remember to save your running config file across to the startup config file after you do any changes, or else those changes will not be available on a reboot. So the show IP interface brief and show IPv6 interface brief commands are there in the switch or the router to confirm our IP address for the interface and give us a summary of its status, whether it's up or down. So we will have labs and some packet tracer activities to do in each one. Now, I'm not going to leave the slides in every step of the way to prompt you to go off and do labs. I'm going to just do one slide at the summary end, reminding you that there are labs and packet tracer activities for you to go off and do. But this one's here to demonstrate the fact that you can actually use the lab files with packet tracer and build the lab inside packet tracer, because it shows you the diagram, how to build it, what ports to connect the cables to, and then you can go through and configure it. Whereas the packet tracer activities, the lab build is already done for you in the packet tracer activities. So by going through and doing the lab side of it in packet tracer, you get to be more comfortable with using packet tracer as you go through. And you get used to using the format of reading the topology diagrams and connecting it up and so on and so forth. Okay, Duplex, just as a reminder, Duplex is how the devices can talk to each other at the same time. So half duplex, we can either listen or talk. Full duplex, we can do both at the same time. Okay, so devices in full duplex communication can send and receive data at the same time. And this is a default setting for the higher speeds, just to be aware. And one of the most common problems we have with duplex is when it's set to auto, we can develop a flapping where the devices can't agree and synchronize up their duplex mode. So one will be half duplex, the other one will be full, and they can't agree, so they swap to the other one, and they're out of sync. It's easy to resolve that. You just go to one end and manually set it to the appropriate speed and duplex setting, and that will stop the flapping that you get with misconfig on duplex. And there you go. Top line, set it manually. It's all done. So we'll move on from that one. Switch ports are easy to configure. Just go in the global config, go to this port interface, and it's either duplex full or duplex half if you need to set it down to there. Speed, and the speed 100, 1000, whatever you need to send it to, and don't forget to save. This is the little thing that does the little flapping on us, Auto-MDIX. This is the little process that detects the type of cable that is connected to the device automatically. So if you plug in a patch lead or a crossover lead, doesn't really matter. You just plug it in and it will detect the type of cable it is, and it will adjust the interface, which pairs of wires it uses to send and receive, depending on the auto detection of the cable. And this is the little issue that we have, that things can come out of sync with each other, and we will have to set things manually. So verification commands: show interface, show startup, show run, show flash for the files in storage. Show version will tell you what type of hardware and software you have. Show history is your command history, and show interface, show MAC address table will give you your various interface configurations and your mapping for your ports and your MAC addresses. Remember, switches learn MAC addresses as they arrive inbound. Okay, so as the frame arrives on a switch port, it records the source MAC address and it says the source is available via the port 5, and that's what's entered into the MAC address table. Show run. Okay, look at all your configuration. Can use the enter key for one line, space for a page scroll. Show interface and then specify your interface. Will give you specific information about that interface. Do not just type in show interfaces, because on switches you have 24 or more on a standard switch, and that's a lot of scrolling back to find the one that you want to actually look at. Okay, so just be aware to specify which port you want to actually get status on, and just look at that one. Now, the things you need to look for is the status being up and the line protocol being up. If those aren't up, you've got an issue. Full duplex, the speed, media type down the bottom are all there, and your MAC address. Each interface port will have a separate MAC address. Alright, so basically this is going through telling you what to look for on the show interface commands, which I just went through on the last slide. So now this is a breakdown of the full show command, and down the bottom here it basically tells you the status of packets traveling through that interface for the last 5 minutes. So it'll give you a speed, average speed rating over the last 5 minutes, how many packets come in, how many have gone out, how many of them were multicast, or then you've got the error types. You have your runts, so frames that were too small, giants, frames that were too large, CRC check errors on your frames. Generally they occur when there's a collision, for example, some form of error during the transmission of the frame, and then you just have your output errors, collisions with other frames while it was trying to send. Basically gets collision notifications, how many times it's reset itself for that port, and whether or not there's any late collisions. In other words, it was clear to send, it started sending, and then something else arrived at late. One of the reasons you could have late collisions is your cable's too long. Okay, the standard says 100 meters. It still works at 120 meters, but what happens is the signal strength can start to get too weak, and the other thing is the time it'll take to get from one end of the cable to the other is longer because there's more cable to travel along, so therefore it takes longer for a frame to travel. So you could get a late collision because of the simple fact of the physics of the distance being travelled. So the slide I'm going through all what those little lovely things are. Talked about it already, so I'm not going to go over them ever, because there's 65 slides to go through on this one, so we need to motor on. Runts, giants, and CRC errors are available as per the show command. Just for status, tells you what's going on the network, and if those numbers are getting very high, you need to start looking at some mitigation to help improve your network performance. So that's what that stuff will tell you. Troubleshooting, show the interface, little thing, if it's up, you're basically good to go. So if it's up, do we have noise? Do we have appropriate duplex settings? So it gives you a basic thing to look out for. I'm not, as I said, I won't read slides to you. They're here as a talking point reminder. Okay, remote access. Telnet is the default protocol for remote access, runs on port 23. The trouble is it's in clear text. So when we use Wireshark, which is just a packet sniffing tool, and somebody's using Telnet to remotely log on to a device, you are giving your password, username and password to whoever is using Wireshark. Because every keystroke can be seen and every echo response. So when you send a keystroke, it goes to the device, which is the red, and the echo, in other words the terminal monitor function that shoots that command or keystroke back to your remote session, is also captured and displayed. So this is why we have admin stuttering along there. SSH is by far a better way of doing it because it's encrypted, and they were slack and didn't take another Wireshark screenshot, because what you would see if you're doing SSH is only your remote side. You wouldn't capture everything coming back like it is there displayed, because SSH is running on port 22, it's secure, so it's encrypted, so you can't see it in Wireshark, even though they show it seen. Okay, show version. Basically, ones we need to come out of this is they'll give you your platform. So this is a 2960 device, and it's using LAN base K9-M operating system version 15.2.7. Okay, configuring SSH. Now, I'm not going to expect you to remember this by a wall of text. I expect you to remember this by doing labs of connecting your consoles using SSH protocol to do your configuration remotely. So there's a few things we need to go through setting up the device to run that. Let's go through that in a lab environment rather than just reading a wall of text. So basically you need to do a few things like have a unique device name, set up your key generators on your device, have authentication, so usernames and passwords locally, and then enable the protocol on your VTY lines, and specify whether you're using version 1 or version 2 of SSH. Again, in a lab environment. Okay, and then you just connect using a client that uses the SSH protocol, such as PuTTY. Any of the terminal emulators will do. Comes down to personal preference, and you log in and provide a username and password, and then you can go in. How you verify it is using the show IP SSH, which will tell you whether it's enabled and what version is, and show SSH will give you the version and encryption methods being used at the moment. So, okay, so HMAC, and it'll tell you line by line what sessions are merged. So here's our in and out. We're using AES 256. Okay, so there's our encryption methods and our user that is using that connection, as in their username. Packet tracer activity for you to do. As I said, this is the only one that I left them in to do. The other ones will just be a slide at their end. So basic configuration of a router or a switch, doesn't matter. We need to configure a host name and then our passwords, enable secret. do not use the enable password, because the enable password is in clear text. Always use enable secret, which encrypts the password. Line console and then line VTYs are then used for our virtual terminals, and we put in our password and tell it to use the password on login. Encrypt the clear text passwords with a low-level encryption, service password encryption. This will only protect you against casual observation. We should always put some form of banner saying that authorized access to authorized people only. Most organizations will have some legal blurb associated with it. Do not ever use the word welcome in your banners, because if you're using the word welcome, that is an invitation extension to the person logging in, which means if they're unauthorized and you've used welcome, guess what? You just authorized them to have access. That was legally a legal case many years ago, when one of the first people they tried to prosecute for illegally accessing a network, they went, but they welcomed me, they invited me in, was the defense, and they won. Okay, so do not use the welcome command in the message of the day. And I think I've said save your configs enough. Okay, dual stacking. This is where we are running both IP version 4 and version 6 at the same time. This is generally done when we're migrating across to V6 or trying to merge systems together and need both running. Now, not all devices will support dual stack, so you may need to upgrade some equipment or operating systems in your network when you need to go to this dual stack operation. So basically what you do is you have both IP addresses allocated to the same interface, one being V4 and one being V6, all across your network. So how do you configure that? Oh, you just use the commands. Now, throughout the course of the command structures, IP refers to version 4. IPv6 is the V6 command. Okay, so here configure the IP address, the 32-bit dotted mask, so our 10.0.5.250 with the subnet mask of being 255.255.128.0, for example. Whereas here, IPv6 address, and we would have a hexadecimal series of address, then a slash prefix, so /64, whatever it is. By default, all your interfaces are shut down, so you need to issue the no shutdown command to activate the port. It is recommended that you put descriptions on your interfaces to indicate what the connection or link does. That's just good housekeeping policy, so that in 2 years when you come back to the device, you know what the link is. So here's just an overview of the config, showing you the version 4 and the version 6, the description, the no shut, and then moving on to the next. Loopback interfaces. Now these are unique little virtual interfaces. They're great for many purposes within configuration. It is a requirement. For example, if we're going to use a routing protocol called OSPF, it's actually embedded to use a loopback interface as its ID when it's talking to other routers within that protocol exchange, because it's got a little quirk. If you aren't using the loopback as its ID, it'll use one of your live interfaces as its ID, and if that interface goes down for whatever reason, your routing protocol shuts down. Your interface will come back up, but your routing protocol will not come back up. So you effectively isolate that device from the protocol, for example. So we use it for testing connectivity. We also use it, as I just said, for instances of routing protocols and things like that. We can make it a interface that is only recognized locally, in other words, to that device, or we can make that interface a interface that can be seen to other devices to check connectivity as well. So a lot of the labs will get you to configure a loopback interface for simulating more network connections than what we actually have. Okay, so that's good for doing that as well. All right, so we're almost there. Interface verification, show IP interface brief, show running config interface, and the interface ID will give you specific information about that interface. Showing IP routes will display the routing table, which if you look for the ones with C, which means they're directly connected, or L, depending on the version of operating system, which means they're a local connection, but generally C is there. Local link is just, that's coming about now because of IPv6. So they're the show verification commands. So what do they look like? So we've got show IP interface brief, which will give you a summary of the IP interfaces. So your interface name, the IP address assigned to the interface, and its status as a layer 1, physical and protocol. So in this case IP, whether it's up and running. Administratively down means it's shut down. The port is not active. Okay, IPv6, we're still looking at the same thing, but basically it will say it's enabled. My local address is this, which is one that is assigned automatically, and then this is the one that is configured, and it'll automatically join some multicast type transmissions which are used for communication and protocols and so forth. So expect to have multiple joins listed. Here's an example of the show running config interface. So basically it's just a printout of the config for that interface. That's it. That just tells you what the config commands were. It doesn't tell you whether it's running or what its current status is. It's just telling you what is in the config file. Show IP route display. This is something you'll become very familiar with as we go. Top portion is the V4, bottom portion is the V6. But basically what it will tell you is this is the network address, okay, the subnet mask, and it'll tell you whether it's connected, local or learnt, and it'll tell you the interface that it needs to use to get to it. So connector network is 10.0/24. The specific local interface is 10.1/32. In other words, this is the actual interface address on this physical interface. So this is the connector network. This is the actual IP address of that interface. And same down here, but it's V6. This is the network. This is the interface it's directly connected to, whether I received it. Alright. You can filter command outputs by putting in parameters after the pipe character, which is the shift key, and the backward slash, which is generally above your enter key. Parameters section include, exclude, and begin. So these filtering parameters become useful in larger config files. You don't want to see all the running config every time you want to look at something. So you put these filters on, say, begin the running config display at a certain point for it. So it will display, if you go show run begin route, it will only display things after the route command. So in router protocols and things like that for IPv4 will be there. We all know and are used to using the up and down arrow keys to get command history for commands that we've already typed in. By default, this is 10 command entries in the history buffer, and we can show the history. So if you've got typed in more than 10 commands, it will show you the last 10 commands used on that device. Okay, summary. Packet tracer, labs. As I said in the following chapters, it'll just be one slide at this point saying, reminder, there's labs and packet tracer activities for you to do. So, in summary, we had a look at the power on steps when you turn on a device. We had a quick discussion on how the LEDs represent things, statuses, visual display. We looked at specifying the operating system that we want to load, where it's located. We looked at gaining remote access to the device, setting up default gateways on a switch, IP addresses on interfaces, passwords, securing remote access, manually configuring duplex and speed of interfaces. We looked at the two protocols commonly used for remote access to devices, Telnet and SSH, and how to configure them, what port numbers they use. I can guarantee you that you will be required to quote well-known port numbers on a lot of these exams, so you will need to know port 22, port 23. We then had a quick overview of how to configure SSH. In other words, you need to have a domain name, host name, users, specify the versions. Okay. Then we had a look at some basic verification commands to prove things are configured and operating on the device. We had a look at the history, so that page up, page down, no, up arrow key, down arrow key, not page up. That's a different thing. And that's it. You can all wake up now. And for those latecomers, thank you for joining us. That's one of the bigger chapters that we've got. As you can see, a lot of it was a revision of ITN. They do expect to have a bigger break between introduction networks and then switching and routing. Not just like the week that we had. All right, end it there.